Okay, everyone, thanks for coming to the application security track. This is the last session of the conference. I think it's been a pretty popular track. I'm sorry to have it end, but we're ending on a high note here. We have Val Smith, founder of Offensive Computing website, and now runs attackresearch.com. Going to talk to us about dissecting foreign web attacks. So thanks for coming, Val.
All right, how's it going? So he gave me a good introduction, so I'll skip that part. All right, so a few notes before I really get into the talk. Colin, who's actually here, and I gave a lot of this content at Black Hat DC, and since we gave that talk, we've experienced some interesting things on our website. There was a DDoS against the server that we're hosted on, which is the Metasploit server, and they were the ones targeted, but you never know what's going on behind the scenes. We saw like 100,000 SSH brute force attacks come from China in the period of about a day after we gave the talk. And then about a dozen or so just random Chinese domains started pointing their domain names at our IP address. We're like, well, why are they doing this? Well, some of our thoughts why they might be doing this to us is like search dilution. They're trying to get our search rankings down, or maybe they're preparing for some kind of bizarre attack. And then a lot of the attacks that I'm going to describe in this talk, we've started seeing against our own server. So I don't know if they saw our Black Hat talk and didn't like it or what's going on, but we'll see what happens after this one. All right, so, what's the problem? People tend to sort of rely on monolithic safety or security mechanisms. And when those fail, you're kind of screwed. And this talk is going to be an example of that, because the whole paradigm, and I know CG and the Full Scope Security guys talked about this yesterday or the day before, about client-side attacks are really the new paradigm of where the attackers are moving. Getting into a system remotely via, like buffer overflows or direct port connections is sort of gone away. And so most companies have relied on firewalls and big monolithic protections, which really don't apply in this new world of the way attacks work. And we'll see that as the talk goes on. So these guys, Chinese hackers, are attacking lots of sites. And we know this because if just looking in the news, there's tons of news articles about, they're hacking Obama's, systems at his place. They're hacking all kinds of people, and there's tons of news articles about this out there. We also have these guys, the Russians. Jose Nazario gave a really incredible talk also at this conference about the Estonia DDoS war and a bunch of other shady things going on. And so we know this stuff is happening as well. We have tons of news articles that bear this out. But worse than those two guys are the guys that we don't know who they are. There's people out there, they're doing stuff, we don't know what their motivations are, we don't know why they're doing these things, we don't know what their capabilities are. And those are the ones I'm really more nervous about, because we're starting to be able to gain an understanding of the Chinese attackers and the Russian attackers. So what are they after? Well, they're after all kinds of stuff. All the traditional identity theft, money, credit card stuff is there. Some of the interesting things we're seeing is this really big growth in the trend of attacking games, massively multiplayer games like Warcraft. I was reading an article that's like a $4 billion industry in China to trade, items in the real world for, money in the real world for items on Warcraft. So that's becoming a huge industry, and if they can get access to your game account and steal your stuff, they're making money off of that. And predominantly now, they're moving towards using your browser to do this. It's really the browser that's their tool to get access to all this information and do what it is they want to do to you. So while these Chinese guys and these Russian guys are doing this, we're all sort of sitting around happily going along on our way, using our computers, using Facebook, and we're about to get hit by the train, basically. Okay, so now I'm going to introduce sort of that was the philosophical sort of intro to the talk. So these guys are using the web in various ways. Their main goal is to push as many users as they can to their malicious sites. They want to gain access to your computer, steal your info, and they're using all kinds of technologies to do this. Iframes is really predominant, and we'll get into that here in a bit. They're getting pretty good. In the old days, or maybe not so old days, attackers were using a lot of malware. Then they started obfuscating their malware to make it hard to analyze and see what's going on. Same thing is going on here. They're obfuscating their attack vectors, their websites, so that an analyst or a sysadmin or even some of these host-based IDSs are going to have a hard time understanding what's happening. So for this particular talk, we analyzed two specific attacks. One we call blog spam, another that's just a website injection attack. But the motivations and some of the techniques in these two attacks are pretty interesting, at least to us. We take these attacks apart piece by piece to show things like source code, network traffic, commands, what they're after, that sort of thing. All right, so first one up is blog spam. So first, I want to go over the process that we sort of use to analyze these types of attacks. In our case, we actually saw them attacking our own blogs, so it was pretty easy to get a handle of what was going on. But then we started looking out there in the world, and they're attacking thousands of blog sites out there. So our process is we take a look at the blog, and we see that there's comments in the blog. You know, in every post of the blog, there's these comments, and they're malicious, and we'll get to why in a bit here. So we start tracing back all the stuff that's in these comments and find links to sites that have malicious code on them. So we start following that malicious code, deobfuscating what they're doing, taking apart their malware, tracking who owns each piece of this, and you know, we'll expand it out here in a minute, and then reverse engineering any exploits or binaries that they have. So the way this attack works is the first stage is they start looking for blog sites, especially high traffic blog sites. Then they look for posts. Many of these blogs allow you to post comments, and all you have to do is register with an email address and say, you know, whatever at gmail.com, and you start commenting. So they're adding their own comments to every post that are kind of bizarre looking, look quite a bit like random word spam. What we've seen them do is, like, I don't know if they have scripts to do this or what, but they grab random chunks of information from sites like Wikipedia, paste them all together, and then link random words inside there and post it to these blogs. A lot of times they'll have non-English words. We see lots of different languages in use here. So this is what one of these looks like. I don't know if any of you have seen this before. It's probably a little hard to read up there, but basically there's a valid post on a blog, and then there's these comments that are just sort of like a big block of random crap with various words highlighted in between there. And we started searching the web and just found thousands. I think we found like 10,000 sites that had this specific one, and there's a whole bunch of different variants of this. A lot of times the comments will start with some like random number or a hash, and I'm not sure why they're doing that, but it's a little bit weird. So we started looking at, okay, well, who's linking to the links that are in these comments? And this is just an example. There's like all these Russian sites that are linking to the same links that are posted inside these comments. So what happens if you follow one of those? Well, you get a site that looks like this. This looks like yet another blog, and there's some random content on here, maybe a few links, but the links don't actually work. The content of the blog doesn't actually mean anything. The page is just the initial entry point to deploy a ton of malware. So the other thing we've noticed is they have a mechanism for registering with the different blogs that they're posting the spam onto. They in this case, all of them were coming from the same domain, so it's kind of interesting to track, okay, who owns this domain, what's going on there. They generate a random user ID for their email address, which is generally about 4 letters and 5 numbers, or 3 letters and 6 numbers, something like that. So we looked into, okay, well, who owns this domain? Well, it's interesting. It's owned by China Construction Bank. Okay, well, maybe they got hacked. You know, they're just a passive victim in this, and bad guys are using them to launch more spam. Well, it turns out, you know, doing a little digging, China Construction Bank is a valid state-owned bank in China, but it's been known over and over again for being involved in malware. In fact, several of the attacks were domestic inside of China, and the executives were executed for doing this. You know, over the years, it's been reported to be involved in phishing and targeting U.S. banks. So they've got like this bank in China. It's still not clear if they're, you know, totally complicit or if they're what's going on. But so you got this bank involved. All right. So we got the email address. We've got the bank that owns the email address. But what is the IP address that's actually making these posts? Well, this IP address is in a different country. It's in Germany. All right, so we got China and we got Germany. We started looking around for, okay, well, how many blogs have this problem? How many blogs have been hit by these comments? And it changes from day to day and from variant to variant, but on this particular case, there was like 7,000 blogs that had this stuff in it. And that's just one variant. So you can extrapolate that out to tens of thousands of sites. If you take apart the comment and look at all the links that are inside of it, one comment had all of these links. And you'll start seeing that a lot of these sites are like Russian, Ukrainian, different types of weird things. And all the language is Italian. Another comment had a similar list but different. So it turns out for this particular one, there were like 5 different domains involved in 5 different countries. So you start seeing, okay, well, let's say we want to track this back and prosecute these guys for distributing malware and exploits. You got how many different languages, different countries. One of these sites turns out to be the Moldovan's government economic website. So why is malware linking to some like bizarre subdirectory on some country's government's website? I don't know if they don't know what's going on, but you start adding all these levels of complexity. You've got 2 different governments involved. You've got 6 countries, 6 different languages. How are you going to track this back and attribute this attack and get to the bad guys? It's going to be very difficult because there's language barriers, there's international barriers. These countries don't necessarily cooperate with each other. Yeah, and I covered that. So we started trying to think about, well, why would they even bother doing this? I mean, who cares about blog comments? Well, if they're driving people to their site, sometimes people might say, oh, I'm curious about the Cretaceous period. I'll click on that. It turns out they're making money in a lot of different ways. When people click on this site, they've got their little advertising affiliate stuff. Jeremiah Grossman talked yesterday about how this kind of thing works. Every time they install adware, spyware, or malware on your box, they're making money. When they steal info from your box, they're making money. Your box also becomes a node in their botnet, they're making money. So at every turn, they have multiple ways of making money if you just click on that link. So now we're going to get into a little bit about, okay, you clicked on this link, it's in all these different countries, what happens? So besides this fake blog HTML, when you take apart that one site that looked like a fairly benign blog, there's a bunch of obfuscated JavaScript. Essentially, they have a bunch of code in there. It just looks like random numbers that when you decode it is actual JavaScript code that's deploying all this malware stuff. The browser knows how to deal with this. It's a little more difficult. But it all happens transparently in the background. So this is an example of what some of the code looks like. You just see a bunch of numbers, basically. So we decoded this, and all those numbers decode to some URLs. One of those is related to one of the URLs. It's a direct link in the comment spam. Okay, so the next thing they do is they set up an iframe to get your browser to start going off to different websites. It's usually like a 1 pixel by pixel frame, so you can't see it in your browser. And you think, well, okay, people know about iframes. Host IDSs might try to detect them, or in-browser protections detect these and stop it. Well, but then they do the code like this. So they're using JavaScript to break up the word iframe so that the word iframe, if you search for the word, a lot of these protections are based on parsing the HTML first before they let anything happen and seeing if this stuff is in there. Well, since they're breaking up all this code and then reconcatenating it in an interpreted way, a lot of these protections don't know how to deal with this. So this gets right through it. So taking apart it, we see all these different redirects that they're doing with iframes. They're going to, essentially it's like a big spider web. You hit one page, branches out to 2, and each one of those branch out to 2 or 4, and each one of those branch out, and you end up with this massive web of malicious sites that your browser is all doing in the background. You don't even know what's going on. I used a tool called Tamper Data. I don't know if anyone's familiar with it. It's a plugin for Firefox. This lets you actually watch what your browser is doing when you hit a page. And I hit one page, and all of these links happened in the background that I didn't know was going on. And each one of these had malicious stuff on them. So it was pretty crazy to try to track back. Every time you turn over another rock, there's more bugs running away and more rocks. So after sifting through all this garbage out there, it turns out one of their main goals is to deploy literally a tool called Porno Crawler. And this actually works. You can crawl porno with this tool. But in the background, it's going to be gathering all the info about your box and profiling it, encoding it up, like base64, encoding it, and shipping it off to this Russian email address. So while you're browsing your porn, you're also giving away all your information. This update online turns out to be a nexus for all this stuff. So I actually have a picture of the porno crawler down there in the bottom corner with the liberty of a little Russian submarine, because it turns out all this stuff is Russian. Even though it began looking like it was China Construction Bank and all of that, by the end we discover it's actually a Russian attack. So after you end up hitting all these pages, all these random exploits, all this obfuscated JavaScript, they deploy a rootkit into your box. So, you know, they're stealing your info, getting command and control, doing all the traditional stuff hackers do. And then this is just an example of what some of the source code looks like before it's been deobfuscated. You can see it's really complex, a lot of garbage in there, kind of difficult to understand. I'm going to skip through a couple of these slides here. They even go so far as to deploy their own Java applets, which do even more malicious things to your system. So, I'll skip a couple of these. You end up getting like a UPX packed binary. Okay, so after they install their rootkits and their malware, you become part of, I don't know if anyone's heard of MPAC. MPAC's sort of a older school web-based command and control tracking malicious database. So this is an actual page on these guys' site where they're controlling all these people that they're hacking. And we found this by deobfuscating all that code, basically. So the nice thing that these guys did for us, probably unintentionally, was the whole web root of all the pages that they have on their server is like world readable. And so if you know the structure of MPAC, we've got a copy of the source code so we know how it's all laid out and what pages there are. You can actually navigate to specific pages inside their website and get information about these guys and what they're doing. These guys were sophisticated in a lot of ways, but they made some dumb mistakes. And one of the mistakes they made was they had their test installation on the same server. So as they're testing their MPAC deployment and their exploits, they're doing it on this server, and then they have another directory where the production version goes for all the people that they're hacking. So we're able to get in here and take a look at, you know, what's going on their server. This is the test installation. They've even got sort of a README here you can see is all in Russian, and it's got like the username and password of their MPAC installation and their database. So it turns out their log files for their test installation were world readable over the web, so we just took a look at them, and there was only one IP address in this log because it was them testing their own installation. And the IP address is the guy's home DSL IP in Russia. So you start out thinking, okay, well, it's the Chinese, right? They're evil Chinese are behind everything, and here they are. They're coming from China Construction Bank. It's really well known to be malicious, and Chinese are after us. Oh, it's the Russians making you think it's the Chinese. Now, what can we do about this guy? Nothing, probably. He's in Russia. What are we going to do? But it's interesting that a lot of times these guys know how to abuse security, but they don't implement it for themselves. So you can use that to, you know, track what they're doing. We could actually go in and see all of their victims inside their MPAC logs. So I have sort of a little flow chart. These slides are up on Attack Research, and I think they'll be on the Boston source page or somewhere. So if you want to take a look at this flow chart later to get an idea of how the whole attack flows out, because it's fairly complex, all the different things it branches to. So there was lots of evasion, lots of obfuscation. We know that they're stealing info and getting money, but we don't really know what all their goals are. This thing changed from day to day. Like, we made some posts about it on our site, and within a few days they came back with slight variation of the attack, with some of the domains changed up, but some of them still the same. So they're like constantly evolving this whole little framework that they have. And the basic thing here, takeaway here, is be wary of these strange comments. Even if it's a blog you know well and you trust the blogger, you don't know who's posting what in there. All right, so the second attack that we're going to talk about, which I think is a little bit more interesting, is what I call Chinese injection. So these Chinese guys are hacking literally thousands of websites in a variety of ways, and it looks like their goal isn't necessarily to compromise the website. Like, they don't care about stealing data from the website. They care about compromising the visitors of the website. So they're going after, high traffic, high profile sites. We've seen them attack vendors who are selling products to people or companies in order to get access to the vendor's customers. They don't care about the vendor's credit cards or anything. They want to hack all their customers that are coming to buy stuff. Same thing, they're going after game accounts, financial info, variety of strange information. And their infrastructure is even more well-defined and robust and quick to adapt. So the analysis process that we follow for this one is pretty much the same as the blog spam one. This particular attack that we're going to describe was an incident response that we did for a customer. And we can't say who the customer is, obviously, but essentially we had access to all their logs and their website and their source code, so we could look at it and find the code that these guys had injected on their website. Go through their logs to figure out what the attack was. And one of the things we notice about the Chinese is often they don't clean up logs. They don't care if you find out that they were there. They're just hacking so much stuff that it doesn't matter. And we don't do anything about it anyway. So yeah, we decompiled all their stuff and reverse engineered it and followed to see who owned what domain, what IP. All right, so the way this attack works is, first thing they do is look for vulnerable sites, and literally they're using 8-year-old SQL injections. They've automated a lot of this, and so it's easy, and they're hitting tons of sites successfully. Once they hack your site with SQL injection, they upload some sort of a backdoor, like PHP, ASP, whatever, so that they get some command and control of your server. Then they add a one-line JavaScript or iframe to every page on your website. So then anybody who visits your site, transparently, while they're surfing around your page, their browser is going to be hitting these malicious Chinese sites in the background, and a bunch of bad stuff happens. Once your client system is compromised, they're going to steal your credentials and all the usual stuff. So one of the things that we do at Attack Research is we tell you everything. A lot of these companies that do analysis on these sort of attacks will blur out the IP and the URL and not provide the binary. We want you to have all the info about the attack so you know what you're looking at. So this is the actual IP address of the bad guys. So some interesting things here. First, they searched the web using the Chinese language version of Google, so google.cn. They crafted their query a very particular way. They're looking for .coms with active server page somewhere in the URL, and the word tennis. We don't know why exactly they picked the word tennis, but some of the conjectures are that Google has become aware of Google hacking, and so if you construct your queries a certain way, it'll actually tell you look like a malicious query. We're not going to let you do it. So maybe if they throw in some weird words like this, it'll still let them search. We also see a whole bunch of other IPs scanning for similar techniques from China. That IP is on the China net, typical malicious network. So this is what the actual log entry of the first, the query where they found this victim. So you can see up here, you got the Chinese version of Google. They set it up and they're like, give us the results in Chinese, only hit sites that are in the US, not any other country, who have .coms and active server pages. So they're getting very targeted and specific with their search for vulnerable sites. So once they find something that's got what they're looking for, they attempt a number of SQL injections. And so in this particular case, the logs showed a bunch of 500 status codes, like error codes. Well, the sysadmin looked at it and said, oh, all their attacks failed because it's just errors. Well, what these guys are actually doing is enumerating, using the SQL database errors, they're enumerating stuff about the server, tables and users and things like that. The sysadmin was like, well, I'm safe because there's no 200 OKs or whatever. They use a bunch of encoding to sort of obfuscate what they're doing. This is probably to avoid IDSs or application firewalls, things like that. So this is what one of their attacks looks like, and you can see it's kind of crazy. There's some hex bytes in there, and it's upper and lower and all this random crap. So they're hitting this vulnerable active server page with this query. So this guy Egypt wrote a really quick one-line Ruby script to decode this for us, and this is what it ends up looking like. You can see it's just sort of standard SQL query stuff. And then Colin over here wrote a much more feature-rich decoder, because it turns out they do a lot of strange things when they're coding their attacks. Like they use nested encoding. So this is what one of their nested encoding attacks looks like. And you can see it's really hard to know what the heck is going on in here. It's just a bunch of garbage. So once we run that through Colin's decoder, we see, oh, okay, well, they're going through the database looking at these different SQL usernames. So we thought, okay, well, this is really peculiar. Like, this attack is kind of unique. We see lots of SQL injections out there in the world, but this uses this like nested encoding, and it comes out a certain way, and they're looking for very specific things. So is that something we can target? Is there a way we can fingerprint that and see who's doing this? So Colin went out and actually found these how-to sites in China which tell you step by step how to do this exact attack. And here's another example. Even better, these sites provide automated tools for doing it. And so Colin got a hold of a couple of those. And so we ran these tools and looked at their output, and it's like exactly the output that we saw in this attack. So, okay, what do we got? We've got Chinese IP address, Chinese language version of Google, results in the Chinese language, how-to sites that explain this attack directly, and tools written in China that output the exact same stuff. All right, so starting to build a case. You can never be sure, but it's getting pretty crazy. So in this particular one, the SQL injection failed, and we started looking to see, okay, well, is anyone else hit by this? Because this is kind of crazy. We found at least these. There's probably another 100 sites doing this, but these were the ones that were doing this exact attack that were all interrelated. All of these sites are in China. All right. So they did the SQL injection for a couple of days. Everything failed. And then I guess they decided, okay, forget the automated tools. We're going to go hit them directly. We're going to, come up with something specific for their site. So they discover a library component of the victim's website that allows you to upload images. So they're like, all right, well, we'll upload an image. They upload an image called a CDX, which is a CorelDRAW file. It's basically a GIF. This image library only allows certain file types, like GIF, JPEG, whatever, and they happen to allow CDX files. In this case, it's a GIF, and we took a look at this GIF because we're like, why would they upload an image? Valid GIF. Inside the GIF is this code. So if you look in the code, there's this name Lion121. Well, we don't know if it's related, but the guy, the general of the CN Honker army, like the big hacker army in China, name is Lion, and that's him. So, okay, this is interesting. Well, it turns out we're like, well, what does this get him? Microsoft IIS, I don't know which versions, might still work, will actually look at a file and interpret any code inside the file. So all they did is they added Visual Basic Script into their GIF. IIS started parsing through that GIF, said, oh, there's Visual Basic Script, let's execute it. And so these guys get a remote shell on the web server using a GIF. I'd never seen this before. I mean, I'd heard of GIFRs, but those are client side. This is server side. The victim's image library looks at the file header and says, oh, this is a GIF file. It's valid. The extension's valid. The file format's valid. It's a GIF. Let them upload it. IIS looks at it and says, we don't care that it's a GIF. It's got code in it. Execute the code. So this is how they got their shell. Now, this is like they found the customer's custom in-house written application. They didn't scan with NIC2 or Nessus or anything. There's no scanning for vulnerabilities. They targeted a specific app that was written in-house by the victim and hit them with sort of a customized exploit that was just for them. So you can see them, they start off with the low-hanging fruit, just basic SQL, and then they move to like, well, we'll custom attack them. All right, so then we start seeing something weird. They start making posts to the graphics file, because once the file is uploaded, you can access it. So they just start posting stuff to it. Like, oh crap, they're posting. You can see there's like a weird, looks like a memory address in there. Turns out what they're doing is they're actually sending their commands to this GIF, and the GIF's executing them. IIS is saying, okay, let's execute them. They do about 5 posts. They create a couple of files. One of the files they create is log.asp, we took apart log.asp, and it's like this well-known Chinese language ASP backdoor. The username they set for this is lion121. It's like, okay. The password was some Chinese character set thing that we don't, I don't read Chinese, so I don't know what it said, but even more evidence, maybe it's a Russian guy that knows Chinese, so he's setting his password in Chinese, but this is getting kind of crazy. So in the logs, we start seeing them talk to this backdoor, and we can determine a few things about the way they do this. The backdoor has this, we actually read the source code, but it has this functionality here. You can show files, so they can look at files on the victim server. They can upload files, they can get a shell, they can do various things. So, we watch some of their gets, we see them grabbing files off the server and doing whatever, and then all of a sudden they switch to posts. The problem with posts is that unless your server's configured differently, they don't record the payloads they don't record the arguments sent to the form. So we sort of lose our ability to see what's going on. We can't really determine exactly what they're sending, but we see a whole crap load of posts. And what they're doing is, the site had like 200 to 300 web pages. They added this one line of JavaScript to every single page on this guy's site. So we didn't see them try to get the database. We didn't see them try to get like customer info. We didn't see them try to spread throughout the internal network. They don't care about the target. They care about the people going to the target. All right, so we thought, all right, let's follow this JavaScript and see what the heck they're doing. Well, this JavaScript has basically 2 more lines in it, which generate iframes. And you notice there's like a $M, so that's sort of indicative that maybe they wrote this code in Notepad or some Windows tool. We saw the 17 Gameo domain and a whole bunch of other failed SQL attempts. So these guys are like mass injecting this stuff. I think we found like 10,000 sites that had this stuff in it. All of these addresses seem to all be related because different attacks will lead with a different domain. They're constantly moving around which domain is first and then which ones they branch out to. But they have this huge framework of Chinese domains that all this stuff can hop from domain to domain. All right, so we thought, okay, well, let's start following each one of these iframes and see what they do. Well, this is an example of what the first one does. There's a lot of code here, but I'll explain basically what's happening is they say, all right, well, let's do this ActiveX control for NCT audio. Let's see if you're running IE7, and if you are, we'll send you off to this IE7 page. So they start kind of profiling. This is almost like mapping the browser of the victim. They're profiling what the victim has installed, and then deciding what exploits to deploy depending on that. So this page deploys a whole ton of different exploits. There was a 0-day IE7 that came out. I think it was in December. They had this on they had that exploit on their page. So if you're running IE7, they would get you with that exploit. If you're not, they'll look for a Flash exploit. If you're not running that, they'll go after Microsoft Access. They'll go after Real Player. They'll go after Shockwave. So essentially, what they're doing is they're hitting you with 1,000 different techniques. They're like, okay, well, if that doesn't work, we'll hit you with that, and then we'll hit you with that, so that they sort of ensure as much ownage as they can get. So we thought, all right, well, let's follow these down. If you look up here, about top third, it says iframe. Let's see. It says basically if your user agent is MSIE7, go off to this iframe at IE7.htm. So we thought, all right, let's go see what's on that page. Well, this was the IE7 0-day, sitting right there on the page. It's all obfuscated up and encoded, but now we literally had 0-day sitting here. And one of the interesting things about this is you can keep an eye on these guys' sites, and every time a new 0-day comes out, before it's like publicly known and all the vendors are screaming about it, these guys are already deploying it in this web framework. So you can take this thing apart and reverse engineer it and build your own. This is what the ActiveX control exploit looked like. So you can see they spend a lot of time making it as hard as possible to read and analyze. Just lots and lots of garbage. So we essentially have copies of all the exploits that they deployed. There's some shockwave flash exploits. So this is sort of the flow of this particular one. You can check this flow chart out later. So there's like thousands of sites hacked with this. They're doing a bunch of evasions and obfuscation in their code. We actually see them updating their exploits all the time. They're constantly adding new stuff. And you can't be sure it's Chinese, but when you add up all of that evidence, it's like, well, it's a pretty good case that it's Chinese. All right, so I've got some bonus stuff, and then I may go back and go over some of those slides I skipped, depending how we're doing on time. So the other day, Ryan from ZDNet posted on his Twitter about this tornado kit. So we've been looking at these malware kits now. We saw the MPAC stuff originally, and then we saw this new Chinese stuff. Tornado is just another one of these types of deployment kits for these exploits. So I thought, okay, well, let me go Google. There was a website out there, I can't remember who it was, who did an analysis on the tornado kit, and they posted up on their blog what the pages look like. Well, they did what the typical people do, which is they obfuscated out the URL and some information about the tornado kit, but they left just enough that we could sort of Google hack the hackers. So we went searching for this and found probably like 4 or 5 sites running this, so it's not really widespread yet. And once we dug into each one of these sites a little bit, they're all tornado installations. And one of the interesting things was each one of these sites had at least one PDF exploit. And that's sort of the new hotness now. Well, these guys have been using these PDF exploits for like months now. So that's just barely hitting the news that PDF's a big deal. These guys have been using it against you for a while. So this is what their site actually looks like. A lot of the different ones that we saw had Google Analytics. So they're trying to make themselves look like some Google ad page or something. I don't know exactly what they're doing. But they made the same mistake that the first guys made in that they left their whole web root world readable. And so if you know the structure of the way Tornado works, you can actually go and look. So this particular directory is where they store all of their exploits. There was something like 20 different exploits in here. So I just went in there and got all their exploits. So now we have a huge pack of web exploits. Some it might be 0 days, I don't know. You can see the dates on these are kind of old. We found much newer ones. So we started poking on a little bit more, and they've got an admin directory. So this is a little bit older, different version of Tornado than I've seen before because it had an admin directory. But all this stuff is viewable, and you can see some of the files have been edited more recently. So this is a live bad guy malicious site that they're updating and doing stuff with. They've got this text file with some actual domains in it. I'm not sure if these are targets or domains that they're using for the attack or what these are. I haven't followed down all the links yet, but it's kind of interesting. But the really cool part was, here's a file with all of their victims in it. So we sort of have a list of all the sites that they've hacked. That's pretty useful. You can go harvest all this information and do what you want with it. So there's some opportunities here. There's a whole bunch of web kits out. I know of half a dozen different ones. If you can get info about them from like WebSense or any of these other vendors that talk about it a little bit and then go look for them yourself, you can sort of, we're going to give a talk hopefully in July or August about phishing for pen testers and how you can deploy your own phishing kits to do this kind of stuff. Well, why not monitor these guys for 0 days, take them, download them, clean them up so you're not, shipping people off to Russia or China, and then use them for yourself, port them to Metasploit. So that's sort of one of the things we're looking at doing. You have to reverse some of their crazy obfuscation, but you can definitely do it. I'm going to show you briefly here, just one sec. So this is the actual Tornado source code here. So you can see a lot of these are like compiled PHP, but there's some useful stuff like the structure of their database. You can see how it's set up. This is the actual, it's count.php. This this is how they deploy out what they're going to send you off to. I don't know how readable that is, but this helps you get a feel for the structure of their site and how they do their all their DAT files that they use for storing information, how they do their SQL updates, because they actually have SQL databases behind these web hacking kits usually, and that's how they track. They can say, okay, show me all the hosts that I've hacked from the US only, or from China or Russia or Brazil or wherever. So they can segregate out by geographic location what they've hacked, and they can direct people to do different stuff. Like they can say, harvest all the data from these hosts, or add these guys to my botnet. So they got this sort of big command and control capability. In here, they enumerate out the browsers. Like if you're running Opera, they ship you off to one thing, Internet Explorer another, Firefox. So you can see they're aware of all different kinds of browsers, and they're shipping you off to different pages depending what your browser is. Some of these they might actually have exploits for. Some of them they might just say, well, we don't want to send them to anything malicious in case they're analyzing us, so we'll ship them off somewhere else. You can see they even gather information about like what OS you're running. They actually care about Windows 95. They care if you're running Apple PowerPC. They check to see where you're coming from. Here's their shellcode. And then here's how they pump you off to all the different exploits. So somewhere in here, I think I might actually have the... I'm not sure where it is, but basically the default usernames and passwords for these kits often are inside. Oh, here you go. So default username root, password nothing, database name tornado. And a lot of these guys don't change that. So not that I'm advocating you go, log into their databases, but it's a possibility. So I think I'm a little early, but I'm going to go ahead and open it up to questions, I think, and thanks to all the people that worked on this. Anybody got questions? Yeah. Yeah, we actually showed we showed a couple here in the talk. One that Colin wrote, one that Egypt wrote. We use a whole bunch of stuff. Sometimes we use like JAD to decompile if they're using applets. We use Firebug sometimes to step through, like debugging the JavaScript that they're using. Sometimes you use tamper data to sort of like pause things and see what the requests are doing. So we use a variety of techniques. There's a Malzilla, which is like malware analysis tool that's sort of built on the browser. You can go use that as well. A lot of times we end up writing custom Ruby scripts for a particular case or situation. The code's in the slides, so if you want to use any of those scripts or see how they work and extend them and then contribute your extensions back to our page, that would be cool. Yeah, question in the back. Oh, so is there like a public blacklist is what you're asking? So people have talked about doing that for a long time. When I was running offensive computing, we had sort of a impromptu list running. And there's a couple of like AV companies out there that's part of the service they provide. I don't know how effective it is because what these guys are doing is hacking sites that you trust. So a lot of times the stuff's going to be coming from places you've already whitelisted anyway. Yeah, a lot of the attacks originate from China, but what we've seen in the past is if you start blocking Chinese IPs, they start coming from US IPs. So unless everybody blocks all of China, which isn't going to happen, it's not going to do you much good to blacklist any of those guys. Plus, they're constantly changing. I mean, they do use the, rapidly changing DNS names, and they hop around on different servers. So I don't know that blacklisting them would be effective, really. I mean, it might be a start, but I don't do it. Yeah, question. Yeah, that's a really good idea. I didn't think about it that way. That's probably exactly what they're doing. They're probably using their MD5 hash to find the sites because they automate all this, right? They're not going in by hand and adding these comments to every page. They've got tools that just like auto log in and blast everything and get past the captchas. We saw yesterday how easy that is. So yeah, that's probably exactly how they're searching for the sites that they've already hacked because they might not know for sure, is by looking for their MD5 sums. I'm going to start searching for those. That's good. Yeah. Yeah. Right. They'll check for valid images, but not file extensions. Yeah. Yeah, I'd never seen this one where they embedded it just like sort of in the middle of the GIF, and the way they did it with CDX was kind of crazy. But the PHP one I've done before as well. There was another question over here somewhere. So you're confirming that they're raising their search rankings by doing these blog posts. That's the yeah. Thanks.
Monitoring the command and control centers for zero days is the other side of the equation. Shouldn't we be trying to take these down either by working with the provider or the upstream provider, saying, hey, loss of nationalists here, people are getting infected by this.
Yeah. I mean, so the comment was, shouldn't we be helping take these sites down? And I agree. And there's some groups like Gadi Evron does something with that stuff, and other people who we sort of contribute stuff to and are a part of. A lot of times it's just not really effective because, like in Russia, my understanding is there's nothing against the law with creating spyware or deploying spyware. It's like part of their business model, and it's cool. So there's not a lot we can do. Depending what they're doing with this stuff, if they get really hardcore, then occasionally you take stuff down. But I think it's difficult to take these sites down, especially because it's like, well, there's 6 countries involved. Who do we coordinate with? And some of these countries don't care, or they don't have certs, or they don't have teams. So I mean, we push this information to the kind of people who do that stuff, and people are working on it, but it's still sort of flawed and not very effective trying to take foreign malware distribution sites down. So I figure while we're waiting for all the takedown orders to go through the system, we might as well be taking their 0 days at the same time. Other questions? Yeah. So I was at a workshop at the Santa Fe Institute with a bunch of like like some Google guy and a guy from Microsoft and a Ameritrade guy and all these big, people. And we went through an exercise to try to figure out what the malware economy looks like. And, all this stuff's not super accurate, but this is sort of what we came up with, which is the guy that writes the malware makes like a couple of $100, maybe 200 to $1,000. The guys deploying the malware make it's like micropayments. They'll make small amounts of money for large blocks of stolen info like credit cards. The security companies then make money protecting against that stuff. And then the people who make the most money are the banks, because every step of the way they're getting a fee. So it turns out the people that make the most money from malware and phishing and all this going on are the banks. People making the second largest amount of money are the security companies like antivirus vendors and firewall creators and all that. The guy actually writing the malware is making the least amount of money in the entire equation. So I've heard all kinds of numbers from billions of dollars to millions of dollars. I don't know how big the malicious economy is, but the people profiting it, a lot of us are in this room. Well, I think that's the model that's in place. I mean, if you talk to a lot of security companies, especially abroad, that's what they end up doing is, these guys will be out operating as black hats for a little while, and then they migrate into the security industry. A lot of foreign antivirus vendors employ directly ex-virus writers. So I think that model's already there. There's no NGO out there doing bounties, but people are migrating from one side to the other. Anybody else? All right, well, thanks very much.